Hello guys, welcome once again to our YouTube channel. Welcome to AdMaths plus Maths. Okay, this is your teacher, Mr. Mars. Okay, we are going to be discussing more problems about small increments. We are done already with the part 1. We are now doing more examples, so this will be the part 2 of the lesson, small increments and approximations. Okay, I'll be giving you 2 problems this time. Let's have a little bit of twist of the problems. Okay, let's read. A curve has equation y is equal to the quantity of x plus 1 times the quantity of 2x minus 3 to the power of 4. Find in terms of p the approximate change in y as x increases from 2 to 2 plus p, where p is small. So it means the increase of the value of the x is p, which is represented by, okay, remember, increase, small increment in x, okay, is represented by this, and it says that is the p. Okay, remember that we all know that dy over dx is equivalent to a small increment of y over a small increment of x. Okay, since we all know all these things now, then we can proceed by finding the dy over dx. You see, it's a product of 2 expressions or 2 functions. So we will be applying product rule, and remember this one, this part, the second function is a function with an index, okay, wherein there is another function inside. So we will be applying chain rule. Okay, what is product rule? Again, we will be recalling. Product rule is if you are multiplying 2 functions u and v, then it will become u dv plus v du. Okay, now let's apply that. Dy over dx. Let's find first what is u. Let's say this is u and this is v. Okay, u now is x plus 1. Okay, the derivative of this one is 4. Okay, I'm using again the cover up method. Bracket 2x minus 3 bracket to the power of 3. Okay, times 2. Don't forget that. Okay, this is very important. If you don't have that, this will be wrong already. Plus what? V du. So what is v? It is 2x minus 3 to the power of 4. Okay, multiplied by du. Du is the derivative of x plus 1, which is 1. Okay, so there you go. Now so basically this will be the u, this is dv, this is v, this is du. Okay, after that we are going to simplify this one, which will now become x plus 1. This is the value of dy over dx. Okay, x plus 1. 4 times 2 is 6. I'll put in the 6 first. 6 times x plus 1. Okay, times 2x minus 3 to the power of 3. 1 times this will be 2x minus 3 to the power of 4. So dy over dx. Okay, how to find out the value of the dy over dx? Basically, you need to know what is the value of the x. And remember, in our part 1, I've told you that the starting value of the x will be the value of the x when you are looking for dy over dx. Okay? Thus, the value of the x will be 2. Okay? This 2 will be substituted to these x's. So, 6 times 2 plus 1, 2 times 2 minus 3 to the power of 3 plus 2 times 2 minus 3 to the power of 4. Okay, there. So dy over dx will be, you put this into your calculator, you will get 19. Okay, because this is 4 minus 3, 1, 1 cube is 1, 3, 1 times 3 is 3 times 6 is 18. This will be 4 minus 3 to the power of 4 is 1. 18 plus 1 is 19. Okay, next. What are we looking for? It is the small increment in y. Okay, we are looking for the small increment of y in terms of p. And remember, small increment in x is equal to p. So, small increment in y over p is equivalent now to dy over dx. What is dy over dx? It's 19. Okay? Which means small increment in y is equal to 19p. Our answer. Okay? Next, let's move on to the next example. Okay. It says in the next example that the periodic time t seconds for a pendulum of length L is t is equal to 2 pi square root of L over 10. Find the approximate increase in t as L increases from 40 to 41. So the small increase in L is equivalent to 1. How did I know it's 1? 41 minus 40 is 1. Next, we are looking for the approximate increment of t. So this is what we are looking for. Okay, approximation. Okay, next, since that is what we are looking for, we need to find out what is the derivative of this, or dy over dx. Remember, dl over dt over dl. Why dt over dl, not dl over dt? Because t is there. dt over dl, because this is expressed in terms of L. T is expressed in terms of L. So it will become dt over dl. dt over dl is equivalent to approximate, or small increment of t over small increment of L. We are looking for the small increment of t. Okay? Thus, small increment of t is equivalent now to small increment of t, whatever is the value of the derivative of this. So let's find out that first. So dt over dl is equivalent to, remember, this can also be written as t equals 2 pi over square root of 10. I remove the square root of 10 there. L to the power of 1/2. Now, since that is how we can write this, then it can be 1/2 times 2 pi over square root of 10. Remember, all these are constant. Even the pi is a constant number. Times L to the power of -1 over 2. Now, let's find out what is the original value of the L. You take a look at the sentence, L increased from 40 to 41. The original value is 40, not 41. Original is 40, so it means it will become the dt over dl is equivalent to 1/2 times 2 pi over square root of 10, okay, times, okay, 40 to the power of negative 1 over 2. If you want to solve this manually, you can do that, but I won't do that anymore. I will just press it into my calculator. Okay, press it into your calculator. You will get that the value of dt over dl is equal now to 1 over 20 pi, or pi over 20. Okay, so that is basically now the value of dt over dl. Anyway, you will come up with the same thing. When you are doing your exam in IGCSE, it would be better for you to use your calculator rather than doing it manually, because remember, in IGCSE, you are time pressured. Okay, so it's better for you to maximize the use of your calculator. But don't forget the process, because the process will give you marks in your examination. Okay, now since I have this one already, then I can apply this formula to find out the approximate value. I always put in equal sign. It should be approximate value. Okay, so change in t over what is change in L, 1, is approximately, okay, 1 over 20 pi, which is now this. Okay, so change in t is approximately 1 over 20 pi, or pi over 20, it doesn't matter. Okay, so these are basically the two examples that I can give you this time about small increments and approximations. I hope you have learned something in watching this video. Thank you and God bless. Please don't forget to like, comment, share, subscribe, and click that bell button to be updated with our new videos.